Chen Tong, can you see this screen, the rate of change?
Can.
Can, huh? You can hear me also, right?
Yeah.
Okay, thank you. We wait for the rest to come.
Okay.
Yes, can hear you. Oh, 10 minutes already. Oh. Why today these people not coming? Okay, right. Hmm. We are still at differentiation. Okay, so far what we have learned on the application of differentiation, they are equation of tangent and equation of normal, uh, turning points, and now we are going to do the third one, problems involving maximum and minimum. Now these problems involving maximum and minimum, they are actually similar to our turning points. Okay, in in graphs, okay, in graphs, the equation actually shows us the graph, and we have a maximum point and minimum point. But in everyday application, we can also um, derive a formula for various physical quantities, and we can also find the maximum or minimum value of the physical quantities, whether it's volume or area or length and so on. We can also find the maximum and minimum value using differentiation. And the way we find the maximum and minimum value for a certain physical quantity is similar to the way we find the maximum and minimum value or the turning points. Okay, they are the same, right? So, so this is the third application. We have how many? Two more applications. Rate of change. Uh, what else? Small change or also approximation. So we have these things, right? Uh, so the problems involving maximum and minimum, the formula, the method, they are all similar to the turning points. Okay, so I'm not going to show you the formula and so on again. So we straight away we start off with the problem. Now these three problems, they are given in your textbook. Okay, the first problem in the exercise, self exercise, 2.11. Okay, so I read the question. A wire of length 80 centimeter is bent to form a sector OPQ of a circle with center O. So we look at the sector over here, right? We look at this sector here, right? Now this sector is actually formed from one piece of wire. So a piece of wire very long, you bend it, okay, two times, and you will form a sector. Okay. So the wire that is given to us is bent to form this sector. It is given that OQ equals to OQ equals to R. OQ equals to R. It means that the radius of the circle, the sector is R. It also means that the other side, OP is also R because they are from the same sector. Okay. Then the next thing they gave us is POQ. POQ is this angle here. It is theta radian. Remember radian and angle, right? They are degree. Radian and degree, they are different. They measure angles, but they are different units. So you still remember how to change from radian to degree and degree back to radian. These are things that you need to remember. Okay, next one. Show that the area A square of a sector of the sector POQ is half R bracket 80 minus 2R. So first of all, you have to find the area of the sector. Okay. Nothing is given except that the wire is 80 centimeter. Now, if the wire is 80 centimeter, it means that the perimeter of this sector, that means the three lines added together, is equal to 80 centimeter. Okay or not? The length of the wire is 80, means the perimeter of this sector is 80. Okay, so we start by saying the perimeter of the sector is R plus R plus S. This one is R, R, and S. So we add the length of these three lines together. So we end up having 2R plus R theta. Again, when we use this formula R theta, you must remember R is in theta is in radian. Theta is in radian. It is given to us that the perimeter of this sector is 80. Perimeter is 80. So the expression that we have found here is equals to 80. Okay. So if the expression is equals to 80, right? Now, if you look at the formula we asked to prove, there is no theta. So if you don't want the theta, you have to eliminate the theta. In order to eliminate the theta, you have to make theta the subject of the formula. Okay. So from this equation, from this given equation or the equation that we have found, you try to eliminate theta by making theta the subject of the formula. So I bring the r over 80 over r. Then the 2 bring over minus 2. So this is the value of theta. Okay, so this is the value of theta. Okay, next we proceed to find the area. Now if we can find the area, that means we can prove this formula. We can prove this formula. A equals to half r bracket 80 minus 2r. So we're trying to prove that formula. So what is the area of the sector? Now we have learned that the area of the sector is half r squared theta. So half r squared. Now if you look at the formula here, there is no theta. So I have to replace this theta. I have to replace this theta here with this thing. With this thing. Okay? With this thing. So I have to replace the theta with this. Okay? Where I get this? From the above equation. So theta is this thing, so I have to replace theta with this thing here. After that, you multiply Okay, you multiply the r into this bracket. Now here we have r square. R square means we have 2r. One of the r you multiply into the bracket. The other r, the other r you leave it outside the bracket. Okay, now, so here r square I split into r times r. One of the r I leave it outside here. Then the other r I multiply in. When I multiply this with r, it becomes 80. When I multiply this with r, then it becomes 2r. So we have proven the formula. So far, any question? Okay. Okay, so you say okay, then we proceed. Okay, proceed. Huh? Okay, so we have proven the formula A equals to this thing. Oh, the second part, B. Find the maximum area of the sector OPOQ. Now, if you want to find the maximum area, now this is the formula for the area. If you want to find the maximum area, that means you have to find the maximum A. Now, for maximum, or in other cases, if they ask you to find minimum, for maximum area, the A over the R equals to 0. Because the maximum point is the turning point. So the turning point, the A, the R equals to 0. Now, when I talk about turning point, I'm referring to the graph of area versus the radius, right? Or if you want to plot the graph of area versus radius, then you get a parabola. So this parabola will have a maximum point, right? So the maximum point is the A, the R equals to 0. Now, this is what we have learned uh, when we were doing the turning points, the maximum point. So I expand the R here. So 40r minus r squared. So expand, I get a polynomial. Well, in this form, it is quite difficult to differentiate. So I expand it into this form here. So when I multiply the half r with the 80, then I have 40r. Okay, I have 40r. When half r multiplied by 2r, I have r squared. Okay, so this is the full formula for the area. Now you want to find the maximum or minimum value of the area, you have to find dA dr. So I differentiate this equation with respect to r. Differentiate with respect to r. So we differentiate with respect to r, 40r becomes 40. R square becomes 2r. Okay. For maximum or minimum value of area, or for maximum or minimum value of A, this thing is 0. The dA dr is 0. That means this thing is 0. So you equate this 40 minus 2r equals to 0. So equate equals to 0. And I have found out r equals to 20. Now r equals to 20 is the value of the radius. But in the question, they ask us the maximum area. So you need to find the area. You cannot leave the answer as r equals to 20 because they don't want the r, they want the area. So you have to substitute r equals to 20 back into the equation here, back into the equation involving a. So substitute back, you have r equals to a equals to 400. Okay, right? Any question? Or repeat? Repeat. You want me to repeat, or you want me to repeat, or you want me to proceed? Yes. Let's lean. Anything? No. Lean. No, no. Okay. So one more time. Now to find the maximum or minimum value of the area, you have to put the ADR equals to 0, right? So when you put the ADR equals to 0, then you found out the value of R. Now, you need not show that this value of R will give you the maximum area, or this value of R will give you the minimum area. No need to prove. Now, if you want to prove, you have to find the 2A over the R square. You have to find the second derivative in order to prove whether this is maximum or minimum. Okay, so you don't have to prove that R equals to 20 will give you the maximum value. Why? Because the question say find the maximum area. So it is understood that it is maximum because they tell you maximum. But in certain questions where they ask you to show that the area is maximum, then you have to find the second derivative to prove that the area you have found is maximum. But in this question, they don't say prove that the area is maximum. So you just assume that it is maximum and find out the area. Substitute R into the equation here and find out what is the area. Okay. Any more question? Any more question? The other girls, they have dropped, I think. Okay, no question, huh? Okay, right. Next. We're going to look at question number 2. Right. Question number 2, a piece of wire of length 240 centimeter is bent to make a shape as shown in the diagram on the right. Okay. So again, this question is like our previous question. We have a very long piece of wire, and you bend the wire. Okay, bend it a few times to make it into a shape as shown in the figure. Okay, bend it a few times, then it becomes like that. Actually, they are trying to tell us that the perimeter, right? The perimeter is 240 because the total length is 240. This side, okay. The total length is 240. So you bend this 240 to make a shape, and that shape has the perimeter of 240. Okay. Okay, right. Then the next part, express y in terms of x. Now, whenever they ask you to prove a certain formula or a certain expression, you have to form an equation. So how to form equation? You equate the unknown with the given values. Now, in this case, the unknown, they are x and y. The given value is 240 centimeter. So you have to equate them. Okay, right. Now, I copy down this diagram here. I copy the diagram here. Right. Now, those length I label in blue color, they are originally from the question. It's not something that I have found. Okay. Now, those green color, now you can see here 5x, 12x, 12x. Now, this green color, they are not given. I try to find them using logic or using whatever knowledge of mathematics that I know. Right? So blue color is given by the question. Green color is what I have found. Okay, proceed. Okay. Yeah, before proceed, I have to tell you how I know the green color here 5, here 12, 12. Okay, right. I explain. Huh? PQ is 24. PQ is equal to this TR. So this TR is bisected by this line here through S. So each of this side is 12, 12 because S is at the center. It's at the center, right? Right. Then how do I know this one is 5x? Pythagoras theorem, right? You draw this imaginary line. Now this dotted line again, they are not given by the question. The dotted lines here I draw it myself. Okay, I draw it myself. So the dotted lines here drawn by me. Now, when I draw these lines, I found out that this is actually an equilateral triangle. When I split this equilateral triangle into two parts, they form two equal right angle triangle, right? Okay. So the right angle, if this is a right angle triangle, and here is 12x, the hypotenuse is 13x, so this one has to be 5x. So you don't know why, then you use Pythagoras theorem to find out. If you can remember the Pythagoras triplets, then you will know 5, 12, 13. So the length here is 5. So far, any question or not? The
Hello,
green,
teacher.
no question. Okay, no question, then we proceed. Now, how to form an equation in terms of x and y, right? You have to equate with this number 240. Okay, 240 is the perimeter. So I add up the 5 lines here, the 5 lines. 24, only one 24. 13x, we have two 13x. Y, we have 2y here. So add up all this, become 50x plus 2y. So this is the perimeter, 50x plus 2y, and the perimeter is 240. So this is the equation I formed, perimeter 240. But the questions say express y in terms of x. Now express y in terms of x, it means make y the subject of the formula. Make y the subject of the formula. So move the 5x over, 50x over, then divide by 2. So you have this equation. So this is the expression y equals to 120x minus 120 minus 25x. So this is what we are asked to show. Next part, show that the area enclosed by the wire is this formula. So again, we have to find the area. We have to find the area. Now, when you try to find the area, it will be in terms of x and y. In terms of x and y, you cannot differentiate. You have only learned to differentiate either the area in terms of x or the area in terms of y. You cannot differentiate the equation using two variables. Right? You can only differentiate with respect to one variable. Okay, right. Next one. So I try to find the area. The area of this shape here is the area of the rectangle T. Okay, here PQRT. The area of this rectangle plus the area of a triangle. Triangle is RST. So this isosceles triangle and area of this rectangle. Area of rectangle is the base times the height, y times 24x. So y times 24x is 24xy. Area of this isosceles triangle is the half base times height. Half base is 24x, the height is 5x. Okay. So as a result, we have area is 24xy plus 60x squared. Okay, plus 60x squared. Okay, right, man. Okay, so we see, okay, I got question, huh? Okay, right. Okay. Okay, if we use the formula of two trapezium, can. Yes. Oh, if you use the area of two trapezium, one trapezium here, another trapezium here, you can also find the answer. right? Can also find answer. But then the parallel side, this is y, then this side is what? Y plus 5x, then multiply with 12x, then multiply with 2. It's the same, right? Uh, can. Then we have here 24xy. Okay, we have 24xy, but the question then no y. So you know you have to eliminate the y. How to eliminate the y? We see how to eliminate the y. So we know the y is this. The y is 120 minus 25x. So the y here is 120 minus 25x. Okay, so this is how we eliminate the y. So replace the y with 120 minus 25x. Expand, and you can get the expression or the equation or the formula that is given here, right? So far, no problem. This one, how to prove the area. Okay, next one. The values of x and y for the area to be maximum. Now, whenever you see area maximum, you must differentiate area with respect to certain uh, variable, whether it's x or y or radius. You have to differentiate the area. With respect to which variable depend on the question. If the question area is involving r, then the ADR. Now in this particular case, the area is involving x, so you differentiate dA dx. Okay, so you want to find maximum or minimum area, right? You have to differentiate. Now this is the polynomial, very easy to differentiate. 2280x, differentiate with respect to x, you have 2280. 540x squared, you differentiate, you have bring down the 2, 1080x. Very simple, right? Very simple. So again, for maximum or minimum value area, dA dx is 0. So the expression that we have found for dA dx, you equate it with 0. You equate it with 0. So how? This is dA dx. For maximum or minimum value of the area, dA dx is 0. dA dx 0 means this thing here 0. So you put this equal to 0. And you find the value of x. Now by right, if you want to find the maximum value of the area, this number x equals to 2 and 2/3, you have to substitute back into the area. You have to substitute back into area. But they didn't ask for the maximum value of the area. They asked for the maximum value of x and y. So you don't substitute back into the area, you substitute back into the x, and the x you have found lah. Then you substitute back into the y here. Where is the y? This is the y. So you substitute back into the y and you find the maximum area. What is the value of the y? Okay, last part, maximum area enclosed by the wire. Now they want to find the area. So you have to substitute back the value of x into the area. So I take the value of x here, 2 and 2/3, I substitute into the area here to find the maximum value of the area. Okay, so you substitute the x here with 2 and 2/3, the x here with 2 and 2/3, then you have to square. Now these things you can use your calculator. I don't have to explain. So finally, when you press the calculator, the area is 3840 centimeters squared. Okay, now these things I make it very simple for you, explain and so on. But you have to try. You don't try, the first question you try, you will get stuck. Cannot do. Okay, you have to think, look at the example, what is the step, Then you look at your problem, apply the same method, look at your own problem and work out answer. If you don't try, then you will be like the other girls like that. You're going to drop out. You're going to drop out. So the key is not how well I can explain to you. The key is not whether I can make you understand or not. The key to getting good result is to work out the problem. No matter how well I tell you, how clear I make it to you, you understand everything. As long as you don't try the question, you cannot do. You look at the question in the exam for the first time, you want to try, blank. Everything is blank. So many of them, they drop out because they didn't try the question. Now, you may say, hey, I try, but I cannot do. Or if you try and cannot do, you put inside the telegram. Then I will show you step by step. Please try, please try. Okay, so last question, number 3. 10 minutes more. Can finish. Don't worry. Okay, 10 minutes more. Now the last question. A factory produce a cylindrical closed container for drink. Cylindrical closed container. It means that there is a top. Now this is a cylinder, the curved surface area, and there's a top and there's a bottom. If it is an open cylinder, probably either the top flat surface or the bottom flat surface is missing. Then it's not a closed container. When they say closed container, it means that the cylinder has 3 surfaces. The curved surface area, right? The curved surface area, top circle and bottom circle. Okay, right. The cost, each container has a volume of 32 pi centimeter cube. The cost of the material used to make the top and bottom cover of the container is 2 cents per centimeter, square centimeter, while the cost of the material to make the curved surface is 1 cent per centimeter square. Show that the cost to make the cylinder is distinct with the radius of base of a cylinder. Okay, right. Okay, right. Cylinder. Now, when you talk about cylinder, there are 2 things that you need to know about the cylinder: the volume of the cylinder and the area of the cylinder. So you must know both quantities, the formula for both quantities. The first, the volume. So what is the formula for the volume of the cylinder? Okay, volume of the cylinder is pi r square h, where r is the radius of the base and h is the height of the cylinder. So if the volume is pi r square h and they give you the volume is 32 pi, so what must you do? You have to equate the two. Now, why you want to equate the two? Because you want to form a formula. Why you want to form the formula? Because you have to eliminate one of the variables. You see, in this question there are two variables, r and h. So you cannot be differentiating r and h at the same time. You can only differentiate r or you can only differentiate h. Okay, you can only differentiate r or you can only differentiate h. So inside this formula or the formula for area, you have to eliminate either r or h. Okay, inside the formula for volume or area, you have to eliminate one of the variable, r or h. So how to eliminate one of it? That is the reason why they give you this volume is 32 pi. Okay, so this volume is 32 pi is to equate the volume with the formula here, so that you can find h in terms of r or r in terms of h. So in this way, when you do the next part, you can eliminate one of the variable. Okay, one of the variables. Okay, now, so I have found out r equals to 32 over r, h equals to 32 over r squared. The pi and pi can cancel off. Pi and pi can cancel off. So the h is 32 over r squared. Okay, now they want to show the cost of the making the cylindrical container. Now to make the cylindrical container, you have to make the area, right? The aluminium foil. Use the aluminium foil, you cut, then make the curved surface area. So the area of the cylinder is actually area of the circle, the top part, and area of the circle, bottom part, and also the curved surface area. So I've written here, right? Area of circle, curved surface area. Area of circle pi r square. 2 pi r square. Top pi r square, bottom pi r square. Then the curved surface area is pi r square h. Pi r square h. Okay, lah? Right. Now, but when you want to find the cost, you have to, how to say, ubah suai. You have to modify, right? You have to modify a little bit. You cannot use this 2 pi r square and pi r square h. This is the surface area. It is not the cost. So in order to find the cost, the top and bottom, there is this one, 2 cent. The curved surface area, 1 cent. So you have to multiply the area with the cost. You have to multiply the area with the cost. Okay, so when you multiply the area with the cost per unit, per centimeter square, you will get something like this. 2 times this, 4 pi r squared. Okay, 1 times 2 pi r h. 2 pi r h. Now h, you have to replace with the h here. The h you have to replace with the h here. This is your h. This is your h. And you have to substitute inside here the h. Okay, you have to, yes. So you have to replace the h. What is the reason for replacing the h? So that the whole equation for the cost is only in terms of r. Okay, why you need to express the cost in terms of r only? Because you have to differentiate with respect to r. Now if there's a h here, can you differentiate with respect to r? Cannot, because the h is not a constant. The h is a variable. So you cannot differentiate the h if the h is there, right? So you have to replace the h with r. Now the whole equation is fully in terms of r. Now can differentiate, right? Okay, right. So what they say, find the cost. So cost, this one, proven already, the cost. Find the dimension of each container in order to produce the minimum cost. Minimum cost means they want the minimum C. They want the minimum C, that means dc over dr is equals to 0. Then another thing is they want to find the dimension. What do you mean by dimension? Dimension means they want to know how much is the height, how much is the radius. Okay, the height and radius, they are the dimension that define the cylinder. So you have to find the dimensions that produce the cylinder. You have to find r and h. Okay, how to find r and h? Okay, for maximum or minimum cost, dc over dr equals to 0. So I have to differentiate this lah. This is the c. So dc dr, differentiate the r square, you have 8 pi r. 8 pi r. Now differentiate this, the r is at the bottom. Okay, When you differentiate the -1, it becomes -2. So the r become the r squared. Then the -1 you bring to the front here. That's why you have the negative here. Okay, then this become an equation when you put it equals to 0, right? You put it equals 0, then bring the negative term to the other side, bring the r here, cancel the pi with the pi, 64 divided by 8, and finally you get r cubed is 8. R cubed is 8, r is how much? R is 2. If you don't know, then you use your calculator, find the cube root of 8. Now, if you find the r equal to 2 is not enough, right? The dimension, there are 2 dimensions there. So after finding the r, you have to substitute back here to find the value of h. So substitute back into here. H is 32 or r squared. So it becomes 8. So R2 and H8, they are the dimensions of the cylinder. Okay, so